Hello world, microcatchan! Another sensor with time. In addition to temperature, it can measure atmospheric pressure. And knowing the pressure in Pascals, we can get the pressure in millimeters Hg and the height above sea level. The BMP180 sensor is applied with ready-made PCB soldering. There are pull-up resistors and filtering capacitors. The sensor has a hardware address, but it cannot be changed. There are 4 pins for operation, 2 for power and 2 for the I2C bus. The inlet window is a small opening that always contacts with the atmosphere and the measurement of air pressure as well as temperature. Connect to the microcontroller. After tuning on the power, the display shows the value of the air temperature, atmospheric pressure. The sensor outputs the pressure value in pascals. Additionally, the value is displayed in millimeters Hg. In addition, the value of the altitude above sea level is calculated based on the current pressure. The board with the sensor is connected to the power buses as well as to the I2C microcontroller bus number 2. Let's carry out a simple temperature test, namely you can touch the sensor body. From this, the temperature rises slowly. The pressure value practically does not change. Let's move on to the electrical diagram. And so the BMP180 sensor is connected to the power supply and the data bus. This is the I2C bus of a STM32 microcontroller, in this case number 2. After processing the measured values, we are sent to the display in order to show them clearly to the user. Learn more about working in the software part. We connect the necessary header files and initialize the microcontroller's peripherals. We initialize the object for working with the display. We initialize the object for working with the sensor. We indicate the used interface I2C. We set the accuracy of the pressure measurement. We start the procedures for initializing and receiving data. Additional functions for obtaining pressure in millimeters Hg and altitude. In an endless loop, after a delay of 1 second, the measurement function is called. When the obtained data is drawn on the display, with the temperature being constant and the hour values in turn. For the sensor, separate files have been created, which collect data on internal registers, time delays, masks for registers, as well as various functions and settings. Depending on the used I2C bus, certain pins are configured. Their mode for operation is alternative open drain. We configure the periphery of the I2C interface. Address 7 bits. Confirmation used. Maximum speed. Control via DMA. Setting up DMA channels. We indicate the I2C data register. We receive or transmit buffer, its size in bytes. Sizes of memory and peripherals 8 bits. The main function is to read data from a register. First, using DMA, we write the register address to the bus. When we restart and read the received data, we adjust the size of the data for recording. We generate a start signal. In the loop, we are waiting for the start signal to be received. We generate the address of the sensor. In the loop, we wait for the address signal to be received. Next, we send the register address via DMA. We do not send a stop signal, instead we do a restart. If the data size exceeds 1 byte, when read through DMA, adjust the data size for the channel accordingly. We generate a start signal. In the loop, we are waiting for the start signal to be received. We generate the address of the sensor. In the loop, we wait for the address signal to be received. For 1 byte buffer, we use the setting procedure using the pooling method. Disable confirmation, interruptions and send a stop signal. When we turn on interrupts and copy the data from the bus to the buffer. If there is more than 1 byte of data, when everything is done by means of DMA. In the initialization procedure, we configure the controller peripherals associated with the sensor. We get special calibration data. In the initialization procedure, we successfully perform 5 steps. An example of them is in the sensor datasheet, page 15. The calculations are obtained using a large number of variables. We do the same in the program. We write the necessary data to the control register. This can be a temperature or pressure measurement. After we get data from ADC registers, when we repeat the algorithm proposed by the developer, the calculated values for temperature and pressure are stored in the fields of a global object. That's all, see you in the next video. Subscribe, microcatchan.